Hello everyone, my name is Will Robertson and I am an education specialist assigned to the Marshall Space Flight Center in Huntsville, Alabama. Welcome to Summer of Innovation 2011. For the next few moments I would like to tell you the different activities that go along in a particular lesson. The theme is Earth and Space Science today, and the lesson is Earth's Attic, the Moon. The activities I will briefly describe will be those of reaping rocks, moon math, cratering, and regolith formation. Well, the Earth is quite old. The Earth has been around for a mighty long time, but the Earth that we know today is not the Earth that was here at the beginning. And that's because of the erosion that occurs on the Earth. We have erosion taking place. We have weather that is occurring at all times. We have plate tectonic, the action of where the continents are moving away from each other. We have earthquakes. We have a lot of things that can change the physical characteristics of the Earth. So, in order to really get an idea of possibly what it was like at the beginning of the solar system formation, we have to go to the attic. In this case, we go to Earth's attic, and that is the moon. Because the moon is a pristine environment. It's basically what we see. What we see on the moon today is what it was like billions of years ago. So the moon is a great place to go to and visit to really see what things were like at the beginning of the Earth's formation. So that's why the title is the way it is. Earth does have an attic, and here we have it. It's the moon. There are activities that go along with this particular lesson, and one of the activities, first of all, let me tell you that the complexity of this lesson would be really moderate to advanced, because students will have to know some mathematic formulas. It's for grades 7th through 9th. And this is what I'm talking about. The students will have to know how to find the area of a circle, the volume of a sphere, and the volume of a crater. So they really need to have some understanding of these formulas. Reaping rocks activity. This is where students go out and collect a variety of different rocks in their neighborhood, around the school ground, or wherever they are, and they're to really scrutinize these rocks, study these rocks, and they really should be different types of or different classes of rocks, like igneous, sedimentary, and metamorphic, and so forth, because what we're trying to do is to get the students to think sort of like a crime scene investigator, trying to really let them look at the minute details that make up the rocks and to list these characteristics, because this will put them in a good frame of reference and teach them what science is really all about. It's observing, it's documenting, and so forth. So the explanation of how to do reaping rocks is very detailed in the lesson plan that it's linked to. The activity where the students will have to know the mathematics formulas would be moon math craters, and this is how you present this. Cratering is the result of primarily impact, be it a meteorite striking the Earth, striking the moon in this case, or maybe a large asteroid. And so what you would do is to simulate a cratering process. And what you see in the top left picture here, or top left image, is the top of a green paper box, and you cover it with flour, and then with cocoa, powdered cocoa, or chocolate, and then you will drop different size spheres into the chocolate at different angles, and you need to do this consistently. For example, you need to have something that is a platform that is able to drop a projectile, again, this case being a different size sphere, at 15 degrees, and then the students are to observe the characteristics of the crater that is made at a 15-degree angle, and then again at a 45-degree angle, and then lastly a 70-degree angle, and then you would compare that with some of the craters that are observed on the moon. And this is why we talked about earlier that the students need to find the area of a crater and the volume and so forth and the depth, because that they really need to know the different incoming projectiles of how the crater is made. Regolith formation, we talk about sometimes lunar soil, but soil is a misnomer. There is no soil on the moon. Soil, by its very nature, would imply that there's some bacteria content in the soil or life forms. Well, so far we have not detected any life in what people refer to as the soil. The better word to use, however, is regolith. Regolith. Regolith is really just broken down rock. And how you simulate this is to get some different types of pasta, rotini, lasagna, and then have a student drop different size rocks that would be analogous to an asteroid or meteorite striking the moon. And eventually all this rock, in this case the pasta, will break up into finer and finer fragments. And that's basically what the lunar surface is like. It's really, again, incorrect to call it lunar soil. The correct term is regolith, which is broken down rock. Well, I hope you have enjoyed this short introduction to Earth's attic, the moon, and we hope that you all have a very successful Summer of Innovation 2011. Thank you for joining us.